Okay, so hello and welcome all. In today's class, we are going to see about regression testing, like why actually we want, what is regression testing and why we want regression testing, and actually why we are studying this topic in software maintenance, why actually it is important in software maintenance. Although you can use this regression testing during from the initial cycle, but like right now if you see like most of the softwares that you see which are available for users, they are being developed on iterative, like they are being developed using some iterative approach. So normally means you capture the requirement, you design the software, and then just you release the software with some basic with some basic features, and then on the back you just modify the software with, like, you want to give some premium support to the software, or if the user get back to you and if he asks you for some additional features, then again you want to put those features in the software. A new version comes, and you want to make sure like the old one that you had and the new features that you are including in the software, both things should work together and the user should actually can use it. So this actually is the main scenario where we actually use this regression testing. So if I come to the main definition in context of software, so this is the main definition. So we have a version 1 where actually our main aim is to develop a program P. So once you develop a program P, the next thing is you need to test this program P with certain test sets, and we denote this test set with T. And once the software or the program that you have developed, this P, actually passes this test, you're going to release this P, like as I told you earlier. But once you get like in version 2, now a user wants to have some functionalities. So what first step would be, you are going to modify this existing software P, and this modified software or the program, now we are calling it as P dash. And then we have to then we need to test this P dash for new functionalities. So the first idea is this unit or the function that you have developed, you need to check that particular function whether it's working or not. Okay, so now it's working. Then the step third is you're going to perform regression testing on this P dash to ensure that like the code behaves correctly, means from it behaves correctly. And the main idea this regression testing is to actually to reuse the tests that actually have been derived from P, and then you need to also identify T dash, which actually is going to be a subset of T. So you don't want to use the exist means the entire set of T. Rather, we are interested in identifying certain subsets T dash with which actually we are going to with which actually we are going to test this P dash. And once this is being done, then you are going to
হুম।
release P dash. Yeah.
কি অবস্থা ভাই? হ্যাঁ, কেমনে কি আপনার ঘটনা ঘটছে কবে?
Sorry. Okay, so I think this one is clear, right? So if I talk about this as an overview or a generic definition, so regression testing is basically is an execution of certain test cases uh, on a program like that we saw earlier, which is P, and it is being done to ensure like that the revision of or the modification that you have done does not produce any unintended faults. This is the first thing, and does not regress. Regress here actually means does not becomes less effective than it has been in the past, because in the past it might be like it was not working properly, but now you have done certain changes and you want to check the overall functionality of the program. So the thing comes where actually we can apply this regression testing, and it turns out that like we can apply this regression testing during the development. Like as I told you, most of the software right now which are being developed, they come in an iterative manner. So no one actually releases the complete software in one go. So during development, you can start doing this regression testing, and also once you do some upgrade or some maintenance in the software. And the second thing is a good regression test gives us like the confidence that we can change the object of test while maintaining its intended behavior. But the main thing here is we need to understand what actually is the main difference between regression testing and the normal testing. So there is a lot of difference between these two terms. For example, if we talk about the availability of test plan, so when you do this, the normal testing for the program, so in that case, this testing actually starts with a specification. You have a specification based on which you have developed the whole software, and you use that particular specification as a base, and then an implementation of this specification you use, and then you also have a test plan. It can be a black box or a white box test case based on the objective of the plan. So so if you see this availability in the main test in the main testing, it is everything is new actually here. So you have to develop this specification and the test plan, the test cases from the scratch. However, if I talk about regression testing, you don't have to start means from the scratch or from the starting. Rather, you are going to use some you are going like you have just modified the program, so you don't have to use uh, means you don't have to build this test case from start or from the scratch. Rather, you're going to use the existing test case, and you need to find out, okay, so what actually can be used within this test case. So the main thing is you need to find a subset from the old test cases, and then you need to also find certain new test plans which actually will not cover that modified part. So there are two things. First is using the existing test plan, but you can't use the whole, because if you are using the whole, then the cost and the time is going to be impacted by doing this. And the second thing is you need to design your own new test plan for that particular modification. So if you see, you are not doing this regression testing from starting, so it's partial in the sense, if I compare it with normal testing. Then the second thing is a scope of test. For example, this testing actually aims to check the correctness of the whole program, because testing is normally done this is done once the software or the program is completely ready, and then you perform this. On the other hand, if I talk about this regression testing, it actually includes retesting both the modified parts, uh, just to confirm like they are doing what they have been developed, and the other thing is the unchanged part, to ensure that they remain unaffected by the recent changes. So if you see this unchanged part, so we are not so this unchanged part does not mean like the whole software, which is because the whole software was not touched. Let's assume like if we have modified one part, and the other and complete other part has not been touched, so it doesn't means like you need to reevaluate the entire untouched part. So it is something like you need to find out like which are the modules or which are the functions which are directly linked with this modification. I'm going to show you this with an example in a code, so that then you can just see this thing in more detail, what this unchanged actually means here. Yes, and this time allocation is also very important. Testing time is normally budgeted before the development of a product, and it is actually a part of development cost. On the other hand, this regression testing time should be accounted for in planning of a new release of a product. So this regression testing actually comes in during the maintenance part, if you see, compared to what this testing is. And if I talk about this development information during testing, the knowledge about the development process is available, because it is actually a part of the whole cycle. However, when you perform this regression testing, you may find out like these testers, they were not the part of the main development team, or they are different from what the previous development team were, and the whole testing has been revised compared to the previous one. Yes, and then other factor is completion time. Completion time for regression testing should be normally less compared to this exhaustive testing, because you are not touching the whole program or the whole software. Instead, you are interested in certain parts that have been modified, and the parts that actually you think needs to be checked because they are somehow related to this modification. So this is something you need to find out. And actually this thing actually becomes complex when you have a very big software. However, we will see within small example like how we can do this regression testing. Frequency is also another factor. Testing occurs frequently during code production. However, regression testing occurs many times throughout the life of a product. Like as I told you, nowadays every product is built in iterative approach. So you're going to see this regression testing happens throughout the life of a product, and possibly once after every modification is made. Okay, so this is the activities actually that takes place during maintenance and regression testing. But before going to this diagram, let me show you a simple example. Then we can move forward. Share. Okay, so this is an example in which we can actually see this regression testing in more detail. Okay, so this is a basic C program. It's a very simple program which actually does what it does is it adds user to the database. So what thing is, for example, let's assume we have a structure. We have a structure here which actually takes integer ID and character name till 50 characters. So this is the initial two things which this structure takes, and we have a function here which actually the main role of this function is to add a user to the database. Now let's assume, okay, so this is the function we have, and for this function, this is the functional testing, the normal testing that we were talking about. So this function actually checks whether you can add a user to the database or not. For example, in this example, we have added user Alice and with an ID 1 and Bob, and then we have set the count to 2. So this is the normal functionality testing for this function that we have written. So now let's assume now this have been released, and now let's assume we want to add a new functionality in this code which actually removes a user. So for once you write this logic to remove the user from the database, you also want to decrease the count, so that just to make sure like the user are in the list who actually are in the database. So you did this, and because of this new function to remove the user, uh, what we can do is we can actually test this particular function again similarly like this. We can do this functional testing for this new feature, where actually we are just checking whether it works or not. Means this removing part does works or not. But if you see, we also want to check we want to perform this regression testing actually to the whole to this functionality, because uh, like in this case we just have two functions, but it can be like we can have multiple functions. But if you see this regression testing, what we are doing here is we are not only checking this, or we are not just doing this regression testing on removal part, but we are also doing this thing on addition part. So if you see in this test case, actually first we are adding the user, and then once you add the user, then you are asking to remove user two, which is Bob, and then again you are using then again you are adding user for Diana, and then you are setting the count is equal to 3 because you have removed the user Bob. And then you want to ensure that like this Diana, the lead that you have added was correctly was added correctly, means after the removal operation. So you want to check both operations simultaneously, because these both operations are going to be done in real time. They can be done simultaneously. You can add, you can remove, you can add. So you need to figure it out, like what are the different what are the different functions which actually are interrelated with each other. And in a complex software where you have multiple functions, you will see it's not like every functions are directly or very heavily coupled with each other. They might be loosely coupled with this cohesion and coupling. So this thing actually comes into play over there. And you will see normally not all software components are coupled very tightly with each other, but the case is where they are actually coupled with each other, you need to check you need to perform this regression testing not only on the new functionality, but also for the other functionality which you think is directly linked with this new modification. And now if I go back to my previous slide, this software, what we have here, this activities, yes, activities that take place during software maintenance and regression testing. Now we want to see how actually this regression testing is part of software maintenance. And with this diagram which you see on your screen, we can easily make out where actually regression testing fits in the whole software maintenance process. So once you have developed the product, and the product or the software is released, you get a user feedback, and based on those user feedback you make some changes, um, and these changes actually means you have captured the requirement, and then based on which the code actually gets modified. And once this code modified, then we have this resolution testing. So again, this context is actually going to change depending on the objective. So here resolution testing actually means the resolution that you have given to the product, the modification that you have done, you are just checking that part again. And if it pass that particular functionality, for example, the removal part, if this removal part works, then you move to the regression testing, where actually you are going to check both things. This regression testing is actually going to involve both parts, the modification thing as well as the linkage part, how this modification is linked with different function, and if is this modification actually aligned with the previous with the previous function. In our case, it was addition and removal of the user. So, but maybe you can just check this regression testing, and you can find out like one of the functions is not performing well. Maybe the count is not getting updated, even though you are removing the user from the database, but still the count is there. So you find out like there is an error in this modification. So you go back to the code modification, and again you need to perform some changes to your code. And once this changes is being done on that modification, on that particular thing, or on that particular function, you again come back to this resolution testing, and you check again this you just check whether this modification is working or not. And it can also happen, you may found like during this resolution testing there are some issues that were unhandled. So from that case also you can go back and you can do this code modification. So this cycles actually continues till you make sure that the modification and the whole software as a whole is actually working. So once you think the test has passed and the software is ready, so the new software version comes into the picture. So if you see, we have in this diagram we have not shown the initial part, because this actually is the software maintenance part from software release to new release. So this is something where this is actually the life cycle of software maintenance, and regression testing actually sits in just between this the old and the new release of the software. So these are very much self-explanatory. So it's not like very difficult to understand, or you need actually my help to understand these concepts. And if I talk about the steps that you saw previously, I think I have just written those steps in sentences. And for example, we will always be given a program P, which actually is being tested on T, which is going to actually produce certain results R. And you will be given a modified version of the program P dash. So our goal is to identify the changes to P, and then we need to select T dash, which is actually a subset of T, because like I told you, you cannot use the entire test set T which you have tested on P, because it is going to be a very time consuming task, and it will need resources, manpower, money, everything. So you need to find out a certain subset T dash to re-execute or to test on P dash. And then once you test this P dash with T dash, and then you have to reestablish the correctness of P dash with respect to this T dash. And you can also in this whole cycle, you may need to create new tests, which is T dash double dash as necessary. So it totally depends on the objective, what actually you are trying to do in the whole scenario. Yes, so you can also create a new test history consisting of results from executing. For example, T dash, the revised T dash can be the revised test history. Or on the other hand, this T double dash that we saw can be the newly expanded test history. So it totally depends, like I told you, how much regression testing you are doing. But if the selection criteria is conservative, then this T to T dash is a part of old test history, and that is still actually it will be valid. Uh, in yes, so when I talk about like this types of regression testing, actually have different types of regression testing. But what I found here if here is like these are the main three different types of regression testing. For example, unit regression testing. So this is actually done. This is actually is a practice of rerunning unit test, just to confirm like that the individual units of the source code still operate correctly. Means after you have done any modification. And this unit test is normally done by the developers, who actually are the main responsible people of doing this modification. And we can assume like these tests are actually the smallest testable part of the whole application. And developers mostly use some automated test frameworks, for example like JUnit or for Java and so on, to evaluate like the modification that they have done is actually working or not. On the other hand, if I talk about this partial regression testing, it actually focus on a specific part of the software system. So you are not just checking or testing one single unit, but it's like the part. But the thing is, instead of running all tests on all components of the system, only a subset of a test is being run. So this subset is actually related to the part of the system that actually are more likely to be affected by the recent changes. So like I told you, like you need to find the means by doing this modification, you need to figure it out what can be um, the other parts which are linked directly with this modification, and then you need to perform this partial regression on that affected area. However, it is less time consuming, and compared to running the full test suites of tests. And this process is normally done by the tester. It is not normally done by the developer. On the other hand, if I talk about complete regression testing, it actually involves rerunning the entire test suite to ensure that the new changes have not negatively impacted any part of the software. So it's not like one region or one part; it's like any part of the software, and the product needs to be regressed, because if this integration is being done in a such a way that every module is dependent directly on other, then the only option is like you need to perform this regression testing on the whole product. And it is going to be a very exhaustive approach. And like as I told you, it is going to include all the test cases to ensure like everything functions very correctly. Okay, so in regression testing, we have certain subtasks to perform, which actually has this 6 main steps. So the first step, which is actually is test revalidation, selection, minimization, and prioritization. Then the second is test setup. Then test sequencing, test execution, output comparison, and fault mitigation. Let's see what these things are one by one here. So test validation, selection, minimization, and prioritization. So here actually we are interested in this P dash. So like you have initially you have a program P, and now you have a modified P dash. So now you want to revalidate, or you want to select, or this selection, minimization, and prioritization is actually a process with the help of which you revalidate this P dash. This means this modification. And it is very interesting to note like all the tests for P will work on P dash, but some do not need to be executed. Some may be redundant. There may be too many of them that may have to rank them. So these things that needs to be done, or in selection, minimization, and prioritization, because you don't want to use the whole test cases in this modified P. And then test setup actually means you are going to place this P in an intended or a simulated environment. Means if you don't have the environment to execute the software or the program, you can have a simulated environment where actually you can test this particular data. Third step is test sequence, like in which order actually you are going to evaluate your modified program P. So it's more about the sequence in which the tests are going to be inputted and to an application, and which may or may not be may be of a concern here. Then you need to execute the test, and you need to verify whether you are getting the intended output or not. For example, whether it is adding and removing the user or not. And then fault mitigation actually means what do we do when a fault is revealed. So we will see these steps in more details in our upcoming slides. So let's go first with the first point, test revalidation, selection, minimization, and prioritization. So basically these are the steps that we follow in regression testing. So the first step is test revalidation. So it refers to the task of checking which test for P still remains valid for P dash, because you don't want to use the entire test suits. So you want to come up with certain test cases that actually are valid for P dash. So this means this step is actually means this revalidation process. The second task is test selection, which actually means the identification of tests that is going to traverse the modified portion of P dash. So whatever you have done, whatever you have modified, you need to find a test case which actually can cover this whole portion. Test minimization actually means you want to remove certain parts of test which you think are redundant, and with certain criteria that needs to be set up during this process. And prioritization actually refers to the task of prioritizing test based on certain criteria, like which tests should go first and which test should go next, and so on. We will see these things with an example in our upcoming slides. So let's see first what this test revalidation is. So like I told you, so like test revalidation actually refers to the task of checking which tests for P actually is valid with this modified P dash. So the main objective of this revalidation is to ensure that the tests that are applicable to P dash are only used during regression testing. And then the next step is test selection, where test selection actually can be interpreted in several ways. For example, validated tests might be redundant, and in that sense, like they do not traverse any of the modified portions of P. This can be the first P dash. This can be the first part, and the second thing in test selection can be the identification of tests that actually traverse the modified uh, uh, portion of P dash. This is actually you want, and this is also referred as a regression test selection problem, where actually you want to identify like which test cases actually can traverse this modified p dash, because like I told you, you don't want to use the existing test case, but you want to come up with some new with some subset of test case that actually is going to traverse. And this actually is being referred as a regression test selection RTS problem, and we will see what this problem is in our upcoming slides. However, it is very interesting to know like this test minimization and test prioritization that we saw earlier is can actually be used as a techniques for test selection. Next is test minimization. So test minimization actually means you want to discard tests which are redundant with respect to some criteria. For example, if T1 and T2 test function are two test function in a program P, then one you can decide actually to discard T2 in favor of this T1. So the purpose of minimization actually is to reduce the number of tests to execute for regression testing. And then we have this test prioritization, which actually refers to the task of prioritizing tests based on certain some criteria. Uh, a set of prioritized tests becomes useful only when a subset of tests can be executed due to a resource constraint, and test selection can be achieved by selecting few tests from a prioritized list. However, several other methods for test selections are available, and I'm going to discuss these things in this upcoming slides. And revalidation actually is followed by selection, minimization, and prioritization. And this can actually be a one possible sequence which you can follow during this prioritization task. This diagram actually shows you what test selection methods you can have. For example, you can have a prioritization based on risk. So this can be one prioritization task, and then you can focus on high impact areas. Similarly, you can develop certain test case. You can have a test case prioritization techniques which actually are designed based on ranks of likelihood to detect detects, coverage based selection, requirement based selection, fault based selection. So if you see all these examples, so they are actually uh, uh, dependent on what actually you want to do and what actually your task is, and based on those tasks and based on the objective that you have uh, in your uh, in your regression testing, you can follow any of these methods, and then you can prioritize which task should come first and which test case can go second, and so on. And then you can have your own test setup where actually you can just check this modified part. Even though if you don't have the entire product, you can have some certain simulators which actually can work as a which actually can work as a replacement. Nowadays, digital twin is one of its a very good example of it, where actually you don't need the entire layer device. You can just put your modified part, and the other parts can be simulated using this digital twin, and you can actually perform this regression testing there. And if I talk about test sequencing, so this test sequencing is also very important. And this test sequencing, to understand this test sequencing, I have taken a simple banking system application example. So if you see, this is something related to this automata diagram, where we have a different internal states of this banking system. And if you see, we have in this diagram we have um, six states, and there are six internal states, and there are certain arrows which actually tells you how the process goes from one state to the other states. For example, if this banking, if we take this banking example, so that it starts first with this initialization part, and then what can be the next sequence in this test? It can be like you can ask you, means the next sequence, the next state can be this login mode where actually the user can enter its ID and and this state is going to once the user enters this ID, then it is going to validate, and if the ID is correct, it gives a user a message welcome, and it goes to the second state, which is request mode. However, if you see, if the ID is invalid, you are still on the login mode, and you again ask for the ID over here. So this is simple banking application. It can have multiple other things, for example, password and so multi-factor authentication and all other things. But let's this example is just to tell you guys like how the sequencing actually works. Then from request mode, once you are in the request mode, you can perform two different operations or two different tasks. First is deposit. So user can enter a certain amount to deposit, and once it asks to perform deposit, means once he enters this deposit, it will go to this deposit mode. Similarly, if it will also means this request mode is also going to show you this withdraw thing. And if he wants, he can also go to this withdraw where he can actually enter the amount. And once he enter the amount, he will be on this withdraw mode, similarly to deposit, where he actually can enter some certain amount. And once he enters amount, the system is going to revert him back with a message okay. And in update mode, the balance is going to be updated. Whatever money he has asked to deposit, it is going to be updated, and he's going to see his balance. And his this internal state is going to show him the balance, and a message is going to be displayed to the user like done. Similarly, we can have this kind of operation for the withdraw task, where actually he can enter amount, and once the amount is checked, checking means whether he has enough balance to withdraw the amount that he has entered. This once so the system is going to confirm, and once he gets the confirmation, the money is going to be withdrawn from his account, and he will go to this update mode. And from update mode, he can see the balance, and this operation is done, and he will go again back to this request mode. So this can be one of the sequence actually that we can follow in this in test sequencing, with some internal state and with some continuous running. So what can be the test case in this case? So there can be multiple test case, but let's see this three test cases here for this banking system. One, the first test case, T1 can be, it can take two input. It can take input sequence ID, and this actually test T1 is just to check whether the purpose is just to check whether the login, that is test login system, the internal state one is actually working or not. So if he enters the ID one, the system is going to check whether this ID is matched or not. If it is matched, and he can also request, means if it is matched, he will get a message welcome. And once he requests to exit the system, the system is going to reply him back with a bye message. Similarly, with T2, actually he can evaluate this deposit functionality, and with this T3, we can actually evaluate this withdrawal process, whether this module is working or not. And then we have this test execution. So this test execution is actually means you need certain infrastructure to select, validate, and to perform this sequence. And there are multiple tools which actually you can go through by your own, and you can just check how actually you can use these tools to perform this certain test execution. It's not like you need to do this execution on a very complex software. You can just use these tools for the understanding of a simpler task, and you can check how actually you can develop your own test cases, and how actually you can navigate through this sequence that we have discussed for any software system, using this avoids or bug time shift x and so on. And I think most of these are open source, so you can go by your own, and you can just check these tools. And the final step is, once you have done this execution of your test cases, the test needs to be verified, and this can also be done automatically with certain test execution tools, just to compare the generated output is actually what you were thinking to be. So this is what I was talking about, this RTS problem, regression test selection problem. So this regression test problem actually is unique. Like in this whole class, we were talking about this regression testing, where actually you don't want to use this the original test sets T. And there can be multiple reasons for this. Maybe it is obsolete, or it is redundant, and other reasons. So what you want is, you need to find out a regression test subset, which is TR in this case, with which you want to retest the functionality of P, uh, uh, so with which actually you want to check this functionality of this p dash in two factors. First will be, you want to check in this p dash the parts that have not been changed, and the parts that actually are directly aligned with this particular function. So if I write this regression testing in a mathematical manner, it can be said like, this whole operation is to minimize this TR, which actually is not a non-obsolete test from T, and you need to find this P dash such that it passes this test TR, and it also pass this test TU. And the main thing over here is to determine this TR, which actually uh, requires a lot of efforts. And for this, actually researchers have proposed different regression test selection techniques, and few of them are like this procedural based, object oriented based, component based, database aspect, and web application. So again, it depends on the objective and the task that actually you want to do. So these are some of the references where actually you can go through, and you can find these regression test selection problem in more detail, and you can also go through this procedural, object oriented, and component based in these references, and you can just check how actually these thing works in more detail, because I have just given you an overview of these things, how this actually works. So from this lecture, actually, you should understand like this regression testing is the main part of software maintenance, and it comes when it's mainly it is being used from the initial development part, but you can also assume like this regression testing actually fits inside the software maintenance, where actually you are performing certain iteration, or you are doing certain changes to the software, and you want means to a particular part, and you want to make sure like this modification has not done any problems to the existing software, and this actually works properly as intended, means as it was designed for the whole application. Yes, so this was today's class. So if you guys have anything to ask, you can let me know.